In today's lesson, we're going to look at basic option strategies. We seek to determine the profit a strategy will produce for a broad range of possible stock prices when the position is closed. For now, we will assume that all option positions are held until the expiration day of the option. We need some notation to proceed. We'll let C represent the call price, and the subscript of 0 indicates at time 0, today. P0 is our current put price, and S sub 0 is the current stock price. T is the time to expiration of our option, measured in years. X is the exercise price on the option, and S sub T is the stock price on the day the option expires. We'll let the Greek letter pi represent the profit from the strategy. N sub C is the number of calls in our strategy. N sub P is the number of puts in our strategy. And finally, N sub S is the number of shares of stock in our strategy. If the number of calls is greater than 0, then the investor is buying calls. On the other hand, if the number of calls is negative, less than 0, the investor is writing calls. If the number of puts is positive, the investor is buying puts, and if the number of puts is negative, the investor is writing puts. For the stock, if the number of shares is greater than 0, we are buying shares of stock, and if N sub S is less than 0, the investor is short selling shares of stock. Let's examine the profit equations for our strategies. If we buy a call option or write a call option, the profit is given by the following equation. It says the profit is equal to the number of calls in our strategy times the maximum of 0, or S sub T minus X. In other words, that's the intrinsic value of the call minus the call premium we paid at time 0. Or if we're writing calls, the call premium we received at time 0. This equation assumes we're holding the position until expiration, and so the stock price at expiration is the relevant stock price in this equation. For put options, our profit is given as the number of puts times the maximum of 0, or X minus S sub T, that's the intrinsic value of our put, minus the initial put premium. Finally, for stocks, the profit from a stock position is equal to the number of shares we own times the share price at the end minus the share price at the beginning. Again, we're assuming the stock is held out to time t. In this chart, we're going to examine the profit from buying a share of stock. We'll start by buying one share of stock at a price of $10. So S0 equals 10. Our profit equation is the profit equals ending stock price minus the beginning stock price. Let's build a table showing 3 possible ending stock prices: $0, $10, and $20. And then for each of these possible ending stock prices, we'll calculate our profit. If the ending stock price is 0, our profit will be 0 minus 10, which is, of course, negative 10. If the ending stock price is $10, our profit will be 10 minus 10, which equals 0. And finally, if our ending stock price is 20, our profit will be 20 minus 10 equals $10. I like to start at the middle observation here, where the ending stock price is equal to the beginning stock price. In that case, we know we'll have 0 profit on the position. So let's start down here with the ending stock price equal to the beginning stock price and plot a profit of $0 at the intersection of these two values. So this green point in the middle of our screen represents the profit when the stock price does not move from the beginning to the end. If the stock price falls to $0, we can see that our profit is going to be negative 10. So we'll come down here to $0 and plot the profit at negative 10. Finally, if our ending stock price is $20, we know the profit will be $10. So we'll come over here on the x-axis to 20 and on the y-axis to 10, and we'll plot a point here. So we have several points that have defined our profit line. We can connect those points with a line and see the total profit chart. So we now have our line drawn on the screen. Let's see what it's telling us. If we look down at the left-hand side here, we can see the maximum loss is just minus S0. The initial stock price was 10, so the most we can lose is $10. There is no limit on the potential profit. This line continues out into space forever, and so when we buy a share of stock, we have unlimited profit potential. Next, we'll examine the profit diagram for short selling a share of stock. The profit from short selling one share of stock at an initial price of $10 is minus. Recall that we said if the quantity is negative, it indicates we're short selling. So I put a quantity of -1 out in front here to indicate we're short selling one share of stock. Let's build a table again to calculate the profit at various ending stock prices. We'll begin by setting our ending stock price equal to 0. And so our profit is minus the ending price, which is 0, minus the original price, which is 10. So we have -10 in the parentheses, a minus sign out front. We get a profit of +10 when the stock price is 0. If the stock price is 10, we have a profit of minus 10 minus 10, which is 0. Finally, if the ending stock price is 20, our profit will be minus 20 minus 10, which equals minus 10. Let's plot these points on our chart and connect them with a line. So we'll start with a stock price of 10 and an ending stock price of 0 and a profit of +10. So we'll come down here to the x-axis, set the stock price equal to 0, and chart our profit here at +10. Next, we'll set the stock price equal to 10, ending stock price, and in that case our profit is going to be 0. We'll draw a point at the intersection of those two values. And finally, we'll set the ending stock price equal to 20. In that case, our profit's going to be -10. So we'll come over here to 20 on the x-axis and -10 on the y-axis and plot a point. We've now got 3 points. We can connect them with a straight line and chart the profit from short selling a share of stock. Stock prices cannot fall below 0, and so our line starts up here on the left-hand side at the stock price of 0 and a profit of +10, and then the line slopes downhill forever. There's no upper limit on stock prices, and so the higher the stock price rises, the more money we'll lose with our position. So let's make a few summary statements here. Our maximum profit from short selling a share of stock is equal to the initial stock price, in this case $10. On the downside, we have unlimited potential losses. Next, we'll examine the profit from buying a call option. Suppose that the stock underlying the call is currently selling for $10. A call option is available with an exercise price of $8, and the market price of the call is $3. If we hold this call until expiration, the profit from the call is given by the following equation. Our profit is equal to the number of calls in our position. We're buying a call, so we'll set n equal to +1. We multiply that by the intrinsic value of our call at expiration, and we subtract the call premium. So here's our chart. We're going to plot the profit from buying a call option with an exercise price of 8 and a call premium of 3. To plot the profit from the call, we're going to calculate the profit at 3 different stock prices. We'll calculate the profit when the stock price is 0, and then when the stock price is equal to the exercise price on the option. That's the point at which the option is either is at the money, and so the slope of our line will change when the stock price hits 8. And finally, we'll also plot our profit when the stock price is $20. So if the ending stock price is 0, our profit is 1, the number of calls we have, times the maximum of 0, or the ending stock price, which is 0, minus the exercise price, which is 8. Then we subtract our call premium, which is 3. So we have the maximum of 0, or negative 8, that's 0, minus 3, times 1. Our call profit is minus 3. Let's see what happens when the ending stock price is equal to 8, which is the exercise price on our call option. Our profit will be 1 times the maximum of 0, or 8 minus 8, minus the premium of 3. Again, we have 0 minus 3 gives us negative 3. So we can see that between stock prices of 0 and 8, 8 being the exercise price, we have a fixed loss equal to the premium we paid initially to buy the call option. Finally, if our ending stock price is 20, our profit will be 1, the number of calls in our position, times the maximum of 0, or 20 minus 8, minus 3. Minus 3, again, is the initial call premium. So 20 minus 8 is 12, minus 3 gives us $9. Let's go ahead and plot these points. So we'll set the stock price equal to 0 and plot the profit at negative 3. So here's 0 on the stock price and negative 3 on the option profit. We'll draw a point there. Then we'll set the stock price equal to 8. In that case, our profit is still negative 3. Finally, if the stock price is 20, we have a profit of $9. We'll connect these points with a line and see what it's telling us. When you buy a call option, the worst that can happen is the option expires out of the money. And the option is out of the money for any stock price less than the exercise price, which is 8. So between 0 and $8, the option is out of the money, and for any stock price greater than $8, the option is in the money. So when we buy a call option, our maximum loss is simply equal to the premium paid to buy the option. The profit potential from buying an option is unlimited. We can also see the break-even point. Break-even occurs when our profit is equal to 0. And so we'll come over here and see where that occurs. Here's our break-even point right here when the stock price is equal to 11. We break even when the ending stock price is equal to the exercise price, which is $8, plus the premium, which is $3, or $11 in total. So for any stock price less than 11, we will lose money on this strategy, and for any stock price greater than 11, we will make a profit. Let me show you a shortcut you can use here. We don't need to calculate profits at all these different stock prices. Instead, we can simply start with an ending stock price of 8. We know we're going to lose the call premium of 3 if the stock price is 8. And so we start by plotting this line. At any stock price less than that, we simply lose our call premium. The option expires out of the money. And so we know we're going to be somewhere along this section of the line here to the left. Finally, for any stock price greater than 8, we know the option will expire in the money. And for each dollar that the stock price increases, we will gain $1 of intrinsic value and thus $1 of profit. So starting here at the initial point of 8 and negative 3, we can simply move to the right $1 and up $1 and draw a point there. Then from that point, move to the right $1 and up $1 and draw another point there. And continue this process. Move to the right $1 and up $1, draw a point. Move to the right $1, up $1, and draw a point. And we keep just doing this across the line here. So without ever calculating any profits using math or algebra, I'm able to plot the option payoff. We know that when we buy a call option, we can choose among several different exercise prices. We also know that if the exercise price increases, the call premium will decrease. So let's look at these two options up here. We're going to plot the profit for two call options. One has an exercise price of 8 and a premium of 3. That's the option we plotted on the previous chart. The second option, which we'll chart with a blue line here, has an exercise price of 12 and thus a smaller premium. In this case, we'll assign a premium of $1. We'll start with the green line, the call that has the exercise price of 8. We know at most we can lose $3 with that option. On the other hand, the option that has the $12 exercise price has a premium of 1, and so we can lose at the most $1 with the higher exercise priced option. As the ending stock price increases, and we look to higher values for the ending stock price, we see that the $8 exercise price option goes in the money when the stock price is equal to 8 and rises up along the green line. And the exercise price of 12 option, it goes in the money when the stock price is 12 and plots along the blue line here. So what do we see? At low stock prices, the option with the lower exercise price can lose more money. So here we see lower X leads to a larger loss. Let's look at what happens at high stock prices, up around $15 or $20. When we have a high stock price, somewhere off on the right-hand side of the chart here, the lower exercise price leads to a higher profit. We could also invert our thinking here, and on the left-hand side of the chart say that a higher exercise price, so as X increases, we have a smaller loss. And on the right-hand side of the chart, as the exercise price increases from 8 with the green line to 12 with the blue line, higher exercise price leads to a lower profit. So we'll summarize. A higher exercise price results in smaller losses at low stock prices and smaller gains at higher stock prices. Next, we'll examine the profit from writing a call option. The profit from writing an uncovered, also known as a naked call, that is one for which we do not already own the stock to deliver in the event of exercise, is given by the following equation. It says the profit is equal to -1, remember a negative quantity indicates we're writing the option, times the intrinsic value of the option at expiration, minus the initial premium on the option. Let's go ahead and chart the profit. This time I'm not going to build a table and calculate the profit at various ending stock prices. Instead, I'm going to note that if I write a call option, I'm going to immediately receive the premium of $3. And at low stock prices, the call option will expire worthless and never get exercised. And so I will make the $3 as my profit. At any stock price less than $8, which is the exercise price, the call will expire out of the money. And if it expires out of the money, the option never gets exercised. Instead, we as the call writer simply pocket the $3 premium and that becomes our profit. If the stock price rises above $8, now we'll start to lose. We're going to have to deliver a stock that's worth more than $8 and only receive $8 from the owner of the call option. I like to use what I call the one-to-one here. If the stock price rises by $1, we're going to lose $1 here. We're going to have to sell a $9 stock and only receive $8 for it. So we can continue this in a one-to-one fashion, moving to the right and downhill $1 at a time. So, without calculating any profits, we've been able to plot the payoff chart. We'll go ahead and connect those dots with a line and see what we have. So, at low stock prices, the option expires out of the money for any stock price less than 8. The option expires out of the money, and we simply pocket the $3 premium as the writer of the call. And so our profit is a constant $3 for any ending stock price less than 8. We can see that our maximum profit from writing a call is only $3. It's the initial call premium. On the other hand, if the stock price rises substantially, down on the bottom right-hand corner of our chart, you can see that we have an unlimited loss potential. So writing call options is very risky. You could lose an infinite amount of money, at least in theory. In practice, the broker will force you to put up margin, and if not, will close out your position. We can also see the break-even. Break-even occurs when our profit is equal to 0, and so here's the break-even stock price. The break-even occurs when the ending stock price is equal to the exercise price, which is 8, plus the call premium, which is 3. You'll notice that the break-even point for the call writer is identical to the call buyer. It might be instructive at this point to plot on the same chart the profit from buying the call, which we did earlier. Let's go ahead and put that profit down here. We said if the stock price is 0, we're going to lose our $3 premium we pay, and that's going to be true for any stock price less than 8, which is the exercise price. So, for any stock price less than $8, the call writer will make a $3 profit, and the call buyer, let's go ahead and label this line, the call buyer will lose $3. Options are a zero-sum game. That means if we add the profit to the call buyer to the profit from the call writer, we get $0. We have $3 to the writer, -3 to the buyer, and so the sum of those two profits is 0, a zero-sum game. Now, at any stock price higher than 8, we know the story. For each dollar the stock price rises, the call buyer will make $1 of profit. And so we can plot this on the same chart just so we can see them both at the same time. So, at low stock prices, the call buyer loses, and as the stock price rises, the call buyer can make potentially an unlimited profit. Looking at the red line, the call writer, at low stock prices, they pocket the premium of $3, and that's the end of the story. The option expires out of the money. But if the stock price rises above the exercise price, which is 8, the call will expire in the money, it will get exercised, and the call writer will lose. When we write a call option, we get to choose the exercise price of interest. We see in the chart here the profit from writing two different calls, one with an exercise price of 8 and a premium of 3. That's the green line on our chart. The blue line shows the profit from writing a call with an exercise price of 12 and a premium of only $1. And so the best that can happen when we write the $12 exercise price call is that we make $1 of profit, and for the $8 exercise price call, the best that can happen is we make a $3 profit. We see that the higher strike price, or exercise price, the blue line here, has lower potential profit at low stock prices, but it also has a smaller potential loss than the green line at high stock prices. Next, we'll examine the profit from buying a put option. Recall that the equation for put profit is the profit is equal to the number of puts that we are buying, in this case 1, times the intrinsic value of the put at expiration minus the initial premium of the put. For our example, we'll use a put that has an exercise price of 8 and a premium of 1. Now, we could build a table and calculate the profit for various ending stock prices, but there's an easier way. We know that for a put, if the ending stock price, down here on our horizontal axis, is greater than the exercise price, the put expires out of the money. So I'm going to come right here to $8, and just write 8 out to the right of that, and in to the left. Now, if the put's out of the money, we're simply going to lose the option premium, which in this case is $1. So I'm going to come down to -1 and over to 8 and plot a point there. I know for any stock price higher than 8, the option will expire out of the money and we'll simply lose our premium. So at high stock prices, our loss is -1 regardless of how high the stock price goes. However, if the ending stock price falls below $8, now the option goes in the money. And if the stock price falls by $1, the option gains $1 of intrinsic value, and so we have $1 more of profit. And we'll continue this line to the left, moving to the left $1 and up $1. This technique only works, of course, if we have units of $1 on the x-axis and units of $1 on the y-axis. So we need to be careful that our chart has proper scaling on the axes to use this technique. We'll go ahead and connect these points with a line. So we can see that our maximum loss from buying a put is simply the premium we paid up front. So I'll write not C0, but this is a put, so we have P0. So the worst that can happen if we buy a put option for a premium of 1 is that we lose $1. At low stock prices, our put goes in the money. Unlike a call option, a put cannot go infinitely far in the money. The stock price cannot fall below 0, and so the profit cannot rise above 7 in this case. Our maximum profit, I'm going to write pi here for profit, is equal to the put premium, the put exercise price minus the put premium. So in this case, we have 8 minus 1, $7 is our maximum profit. We also have a break-even point. Let's see where that is. Break-even occurs when we have $0 of profit. It occurs right here when our stock price is 7. So the break-even also occurs when the stock price is equal to X minus P0. So break-even when the ending stock price is equal to the exercise price on the put minus the initial premium on the put. So at a $7 stock price, we break even. For any stock price less than 7, we make a profit. Notice one difference here. The maximum profit on a put is limited. When we looked at a call, the maximum profit is unlimited. This diagram shows the profit from buying puts with various exercise prices. The blue colored line is a put with an exercise price of 12 and a premium of 3. The purplish line is our original put. It had an exercise price of 8 and a premium of 1. We notice that the low exercise price put has smaller profits at low stock prices and higher profits, or rather a smaller loss, at high stock prices. Let's invert the thinking there and write it another way. So recall the blue line here is our higher exercise price. So at a low stock price, the higher exercise price leads to a higher profit. Then we'll come over to the right-hand side of the chart. At high stock prices, the higher exercise priced put has a larger loss. We paid more for the put, it expired out of the money, we lost the premium. Now we'll examine the profit from writing a put option. Here's our profit equation for puts. Our profit is equal to -1, the minus indicates we're writing the option, times the intrinsic value of the put at expiration minus the initial premium on the put. We'll use the same data for this example that we did before. Our put will have an exercise price of 8 and a premium of 1. Okay, let's think about this. We're writing a put, so we're going to receive the premium, and that will be our profit if the option expires out of the money. In this case, the exercise price is 8, so the put will expire out of the money at any stock price higher than 8, and the put will expire in the money for any stock price less than 8. Let's go to an ending stock price of exactly 8. If that's the case, we're going to pocket the $1 premium, and that's the end of the story. For any higher stock price, the put expires out of the money and does not get exercised. We, as the writer of the put, collect the $1 premium, and that's our profit. So at high stock prices, we have a fixed profit equal to the premium on the put, $1. As the stock price falls, the put goes in the money, but because we're the writer, we will start losing. For each dollar that the stock price falls, we will lose another dollar. And so we can use our one-to-one technique and come down here and plot the profit for low stock prices. I filled in the line here. We can see, so when we're writing a put, our maximum profit is simply equal to the initial premium on the put. In this case, $1. Down here on the left-hand side, we can see our maximum loss. In this case, it's going to be minus the exercise price minus the initial premium. So we have 8 minus 1 is 7, with a minus sign out in front. We can lose $7. Recall that for call options, the writer of the call has an unlimited potential loss. For puts, the loss can be large, but there is a limit to it. We can also see the break-even point for the put writer. Break-even occurs when we have 0 profit. And so the break-even occurs when the ending stock price is equal to the exercise price minus the initial premium. Like call options, put options are a zero-sum game. Let's plot on this same chart the profit to the buyer of this put option. We know that the maximum profit is 7. If the option expires at the money, that is, if the ending stock price is equal to 8, which is our exercise price, that person will lose $1, and then for any stock price higher than 8, that person will continue to lose $1, that person being the buyer of the put option. Let's connect those points. So again, our red line here shows the profit from buying a put, writing the put, and our green line shows the profit from buying the put. The green line is -1 over to the exercise price and then rises up as the stock price falls. Put options are a zero-sum game. For any stock price, if we add the profit to the buyer of the put to the profit of the writer of the put, we get 0, a zero-sum game. When we write a put option, we get to choose the exercise price that we desire, and we can see from this chart that for higher exercise prices, this would be the green line up here, at a high stock price we have a bigger profit, and at a low stock price we have a bigger loss with the higher exercise priced put. Next, we're going to examine the profit from a strategy known as a covered call. In a covered call, we write one call option for each share of stock that we owned. This strategy is not riskless, however, it is less risky than owning the stock by itself. Let's look at our profit equation. It looks complex, but it's really just a sum of two equations we've already seen before. It says the profit is equal to the number of shares of stock we own times the ending stock price minus the beginning stock price. We saw that equation before. We used it to plot the profit from buying a share of stock. Next, we're going to write call options. If we write, then NC is going to be a negative number. So we'll have a negative number here for NC times the intrinsic value of the call at expiration minus the initial premium on the call. So down here it says that the number of shares we own will be positive and the number of calls is negative. In other words, we're writing calls, and for each share of stock that we own, we're going to write one call option. Here's our example. We're going to buy one share of stock at an initial price of $10, and we're going to write one call option with an exercise price of 8 and a premium of 3. Let's start by plotting the profit from the stock. We know that if the ending stock price is equal to the beginning stock price, we make $0 of profit. So we'll draw a point at the intersection of those two values. We also know that if the stock price falls to 0, we lose our entire investment. We lose $10. Finally, if the stock price rises to 20, we'll make a $10 profit on our stock. We'll connect these 3 points with a line. So the green line shows us the profit from buying one share of stock at an initial price of $10. Now we'll plot the profit from writing a call option with an exercise of 8 and a premium of 3. We know that if we write a call option, we will collect the premium. There's $3 in our pocket. That's a $3 profit. And for any stock price less than 8, the option will expire out of the money. And when the option expires out of the money, we as the call writer simply pocket the premium. So at low stock prices, the profit from writing the call is along this section of red line here. Let's go ahead and label that. If the stock price rises, the call goes in the money, where the writer loses when the option goes in the money. And so for each dollar that the stock price rises, there's one more dollar of intrinsic value that we will lose as the writer of the option. So the red line is the same as we saw before, the profit from writing a call option. Now we want to combine these two lines and get our total profit. If the stock price is 0, we have a $3 profit on the call and a negative 10 on the stock. If we add 3 and negative 10, we get $7. The next point we need to look at is the point of inflection here, where the call line has the bend in it. If the stock price ends at 8, we're going to make $3 on the call, and we're going to lose $2 on the stock. So positive 3 and negative 2 gives us positive 1. And so the profit from our combined positions we'll plot here. Finally, we need to see what happens when the stock price is greater than 8 at the option expiration. There's a shortcut we can use here. We could simply come over to $20 stock price and add these two numbers together. So let's see what we have. We've got negative 9 on the call, and we have positive 10 on the stock. So negative 9 and positive 10 gives us $1. We could draw this point here, but there's another shortcut we can use here. Let's go back to our original point here when the stock price is 8. We know that if the stock price increases by $1, I'm going to lose $1 on my call, but if the stock price increases by $1, I'm going to make $1 on the stock. So I have a negative 1 profit on the call and a positive 1 profit on the stock itself. Those exactly cancel out. And so the profit will be the same as it was at the prior stock price. And that's going to hold true for any stock price greater than 8. We're going to have a flat line representing our combined profits at stock prices greater than 8. So the black line here is our covered call. I like to call it the combo, the combined profit. Let's look at the profit line for our covered call here, the black line in our chart. At high stock prices, over on the right-hand side of the chart, we see that our payoff is flat. We've given up the upside potential from the stock itself. The stock is making money, but we're losing on the call option and offset the profit on the stock. So we have fixed losses on the right-hand side. On the left-hand side, at low stock prices, moving along this section of the curve here, we see that we're better off with the covered call than with the stock by itself. So relative to the stock, we're better off with the covered call. But at stock prices above the exercise price, we're worse off. So what a covered call then does for us is it provides some downside protection, some protection when the stock price falls, but we give up our upside potential. We don't make profits as the stock price rises. When we create a covered call position, we get to choose the exercise price on the call that we're going to write. These two charts show the total profit from two different covered calls. On the left-hand side of the chart, or left-hand chart, we have a call option with an exercise of 8 and a premium of 3. On the right-hand side, we're going to create our covered call using a different option. This one has an exercise of 12 and a premium of 1. We see by comparing the two graphs that a low exercise price offers the most downside protection. That is, we're better off with that low exercise price call than we are with the high exercise price call. On the other hand, at high stock prices, with the low exercise price call, our maximum profit is only $1, and with the higher exercise price call, we can see our maximum profit over here from the combined position at $3. Now we'll look at another strategy known as a protective put. In a protective put, we buy one put option for each share of stock that we own. Again, it does not produce a riskless strategy. However, it has less risk than owning the stock by itself. In a way, buying put options is similar to buying an auto insurance policy. When you wreck your car, you get to give your car to the insurance company, and they have to pay you the value before it crashed, the higher value of the car. When you buy a put option, you get to give the share of stock to someone else, and they have to pay you a higher price than the market price for that share of stock. Okay, let's look at our profit equation here. It says the profit is simply the number of shares we own times the change in the share price, the ending price minus the beginning price. We saw that equation before, simply the profit from buying a share of stock. Out here we're going to buy a put option. Because we're buying puts, N will be positive. We multiply that by the intrinsic value of the put at expiration minus the premium we paid to purchase the put. The number of shares of stock we own is positive, and the number of puts here is also positive, indicating we're buying puts. And for each share of stock we own, we buy one put option. So let's plot the profit from a protective put. We're going to buy a share of stock at a price of $10, and we're going to buy one put option with an exercise price of $12 and a premium of $3. I'll plot the profit from the stock in green here. We know that at the ending stock price is equal to our initial stock price, we make zero profit on the stock. Same line we drew on the prior diagram. We also know that if the stock price falls to zero, we lose the entire $10 we invested in the stock. And finally, over on the right-hand side of our chart, if the stock price rises to 20, we'll make a $10 profit on our stock. We'll connect these points with a line. So the green line shows our profit from buying 1 share of stock at an initial price of $10. Next, we're going to buy a put option with an exercise of 12 and a premium of 3. Now we know that when we buy something we have to pay for it, so we're going to immediately lose the $3. Let's go to the exercise price of 12 and -3 and plot a point there. At this stock price, the put expires at the money and we lose our $3 premium. At any stock price higher than 12, the option expires out of the money and we lose our $3 premium. If the ending stock price is less than the exercise price of $12 on our put, it will go in the money and we'll make a profit. So I can draw a little line up here right at $12 and say we're out of the money at stock prices higher than that, and so we lose the $3 premium, and if the stock price falls below $12, the option is in the money. For each dollar that the stock price falls, we'll make $1 more of profit. And so we can draw a series of lines going to the left $1 and up $1 to plot the profit from our put. We'll connect these points with a line. Now we need to combine the profit from the two positions. If the stock price is 0, we lose $10 on the stock and we make $9 on the put. So -10 plus 9 gives us -1. Next, we need to come over here to the exercise price, where the put option line makes a bend. Let's see what our profits are. We have -3 on the put, and I have +2 on my stock. -3 plus 2 gives me -1. So we're going to plot right here. Notice that at low stock prices we have a downward sloping red line and an upward sloping green line. They're going to exactly offset, and that's why the combined profit from those two is a flat line, in this case at -1. Next, if the stock price rises above 12, we're going to lose a constant amount on our put, but we have increasing profits on our stock. And so let's see what we have here to the right. We've got -3 on our put, and I've got +10 on my stock. -3 plus 10 gives me $7 of profit. I can start at this point here, my at the money position, and notice that if the stock price rises by $1, nothing happens with my put, but the stock makes another $1 of profit. And so we've got, again, this one-to-one relationship here. The line is upward sloping because the stock is making money as the stock price rises. We'll connect these points with a line, and we have our protective put, or I'll call it the combo, the combined payoff from the two positions. Notice this line looks substantially different from the covered call. At low stock prices, the worst that can happen is we lose $1. So we have good protection on the downside here. We'll call this downside protection. And very different from the previous diagram, at high stock prices we continue to make a profit. So we will say that we participate in the upside. Protective puts work better as a hedging instrument than covered calls. They give us downside protection, and they allow us to participate in the profits on the upside. So why not use a protective put always? The reason is we have to pay for the put option here. And when we pay for that put option, we immediately lose the $3 premium. When we use the call option, we were writing the call, and therefore we received the call premium and were immediately better off by that amount. When we create a protective put, we have to choose the exercise price on the put option in our position. Let's look at these two charts which show the payoff from a protective put. In the left-hand chart, we have a put with an exercise price of 8 and a premium of 1. We'll notice that the most we can lose with this position is $3, but at a stock price of 20, our profit is 9. Now we'll go to the right-hand chart. We have a protective put with an exercise price of 12 and a premium of 3. So the right-hand chart has a higher exercise price on the put. Notice our maximum loss here is only $1. So it provides better downside protection if we have a higher exercise price. Unfortunately, when the stock price rises, we make less money because we paid more to buy that protective put. At a $20 stock price, our profit here is only $7. On the left-hand chart, when the stock price was 20, our profit was higher. It was $9. Next, we're going to create what are called synthetic puts and synthetic calls. These are based on the put-call parity relationship we examined earlier. We said that the put price was equal to the call price minus the stock price plus the present value of the exercise price. We could solve that equation for the call premium and rewrite it as the call premium is the put premium plus the stock price minus the present value of the exercise price. Now we can ignore this last term here, the xe to the minus rt. We can ignore this and still create instruments that have payoffs like we want. I'm going to rewrite this first equation. I'm going to write P squiggly equals C minus S. And what do I mean by this? Well, we have a plus sign in front of the P over here implicitly, so that says if we buy a put, I'm going to interpret the equal sign here differently. I'm going to say buying a put is like, or behaves like, and then on the right hand side we have two things. The C is buying a call, it has a positive sign, and so we're buying, and then the stock has a negative sign in front, so we must be short selling the stock. So buying a put is like buying a call and short selling the stock. Or we can reverse the equation. We can say that if we buy a call option and short sell the stock at the same time, we have something that acts just like buying a put option. We'll plot that and see that relationship in a minute. So the right-hand side of this equation is known as the synthetic put. There is no put on the right-hand side, but if we do these two transactions, buying a call and short selling the stock, we have created what's called a synthetic put. When options first started trading on the exchange in 1972, there were no put options available, only call options. But option traders already knew the put-call parity relationship, and so they were able to create synthetic puts even though they did not exist in the marketplace. Let's examine the the bottom equation here of the two at the top of the page. I'm going to rewrite that as C. I'm going to use my approximately equal to P plus S. So the right-hand side of our equation says if we buy a put and, so the plus sign is and, we have a positive S, so that's buying a stock. We have something that behaves just like a call option. So the right-hand side of our equation is a synthetic call. If we buy a put option and we buy the stock the put option is written on, then we have a synthetic call option. Let's create our own synthetic put. How are we going to do that? We're going to buy a call option and short sell the stock. So the stock price originally is $10. So we'll go to 10 and 0 and plot a point there. If the stock price doesn't move, we don't make any money. Now, because we're short selling the stock, we know the line is going to be downward sloping. If the stock price falls to 0, we make a $10 profit. And if the stock price rises to 20, we're going to lose $10. Let's connect these points with a line. So the green line shows the profit from the second part of the equation up here, short selling the stock. Now we need to buy a call option with an exercise price of 8 and a premium of 3. So I'm going to come here to $8. We know the call is going to be in the money at high stock prices and out of the money at low stock prices. So as soon as we buy that call, we lose the $3 premium, and we will do so for any stock price less than $8. Next, if the stock price rises above 8, the option goes in the money and we profit. So if the stock price increases to 9, we make $1 of profit, or $1 more of profit. And we'll continue this relationship off onto the right-hand side here. Each time the stock price goes up $1, we have $1 more of intrinsic value, and so we make $1 more of profit. Next, we need to combine the payoff from the two positions. So if the stock price is 0, I lose $3 on my call, but I make $10 on the stock. That's a $7 profit. We need to next look right here where the option is at the money. That is an ending stock price of 8. Again, I lose $3 on my call. I make $2 on the short stock. And so -3 plus 2 gives me a -1. We'll connect those points with. Next, we'll examine what happens when the stock price rises above 8. Let's go over here to the right-hand side of our chart. We've got, at a $20 stock price, we've got $10 loss on the stock, and we've got a $9 profit on the call. So -10 plus 9 gives me -1. We know this black line I'm about to draw here is going to be flat. We know that because for each dollar we move to the right, the red line makes $1 of profit, and the green line loses $1 of profit. So the black line here is our synthetic put. And sure enough, the shape of this black line looks identical to the shape of the put option we plotted earlier. So by using a call and short selling the stock, we create something that acts just like a put option. In this diagram, we're going to create a synthetic call. And we noted a few slides back that if we buy a put option and we buy a share of stock, we've created something that acts just like buying a call option. So let's do that. We'll start with buying a share of stock for 10. We know the story now. The ending stock price is 10. We make 0 profit. If the stock price falls to 0, we lose our $10 we invested in the stock. And finally, if the stock price rises to 20, we'll make a $10 profit from owning the share of stock. So our green line shows us the profit from buying the stock, which is half of the equation for the synthetic call. Now we need to draw in the profit for buying one put option. It has an exercise price of 12 and a premium of 3. So we're going to go to 12 and 3, $12 and -$3 that is, and draw a point there. We know for any stock price to the right of that, the put option is out of the money, and we'll simply lose our $3 premium. So we'll have a flat line at -$3 for any stock price higher than 12. What happens if the stock price falls? The option goes in the money, and if it does, for each dollar the stock price falls, we'll make another $1 of profit. This should hit the intersection up here at x minus p. 12 minus 3 gives us $9, sure enough. Now we've got our put and our stock on the chart. All we have to do is add those two lines together. We'll start here at a stock price of 0. I've got +9 on the put, -10 on the call. That gives me a combined profit of -1. I'll show you a little shortcut here. My red line is downward sloping, My green line was upward sloping, so those things are going to cancel each other out. Our profit will be constant. We'll go all the way over until we hit the exercise price of the put, right there. Now what happens? At any stock price higher than 12, we have a constant loss on the put, but we have increasing profits on our stock. And so the line is going to increase at a 1-to-1 ratio, just like the stock profit is increasing at a 1-to-1 ratio. We can check our math. Right here we have a -3 and a +10 gives us $7. So we plot the black line, which is the combined payoff from buying a share of stock and buying a put option. And we notice this black line, which we're calling the synthetic call, has a shape identical to the plot we made earlier from buying a call option. So that's how we create synthetic calls. We buy a put and we buy a share of stock. This concludes our discussion of basic option strategies.